So this is the last problem in 6.2 with the natural base E. So one of the common real-world uses for E, like I mentioned earlier, is that it's used when we are finding and compounding interest continuously. So this can be used a lot with banking accounts or credit cards or mortgages, things that are constantly compounding interest. So here we've got a situation where we're trying to compare two different bank accounts. So you and your friend each have accounts that earn continually interest that's compounded. So before we do that, let's go back and look at the general equation. So this is our general equation for interest that's compounded continuously. So it's a little different than our compound interest one that we looked at last section. So we see right here, when interest is compounded continuously, A, the amount in your account after T years, is given by the formula P equals E to the RT power. Now, just like our compound interest formula, P is the principal, and R is the annual interest rate expressed as a decimal. Now notice we don't have anything of that like 1 minus or 1 plus R over N. Because we're compounding our interest continuously, we're using our natural base E times our continual interest rate times the total number of years that we're going to be calculating this over. So this is our general formula. A equals P, our initial amount, times E to the RT power. Let's go back and look at our problem. So this right here is a graph that represents our friend's account. Okay, so again, look at, starts at the point 0, 4,000, and it goes up. And this shows us the rate at which it goes up over. So we have some information about our account. So we have an equation. Our balance can be modeled by this equation. A equals 4,500 times E to the 0.4 times T power. So which account has greater principal? Which has a greater balance after 10 years? So with a type of word problem like this, we want to go through some steps and not just rush into things. We want to make sure we understand everything that we're given and everything we're trying to calculate. So first, let's make sure we understand the problem. So we've got a graph that represents our friend's problem and an equation that represents our problem. And both of these accounts are going to be used in the problem. So first, we're going to be asked to identify the greatest principal and the greatest balance after 10 years. So we need to first find the greatest principal and then find the greatest balance after 10 years. So we should be able to find our principal and account balance after 10 years. Then we can look at the graph and seeing the points that we have, we should be able to compare them. So first, let's look at our equation. So we've got A equals 4,500 times E to the 0.4 T. That's in this form that we just looked at. That's in the form of our continuously compounded interest. So let's pull what information we know from there. Now remember, sorry about that. Now remember, P equals 4,500. This initial amount right here, P, in our equation is just 4,500. That just means our principal is 4,500. Now, if we're trying to calculate our balance when T equals 10, we just go ahead and plug it in. We get 4,500 E times the power of 0.04 to the 0.4 times 10. So 4,500 times E to the 0.4 power. We end up getting 67 13.21. That's our exact balance when t equals 10. Okay? Now, we can look at our friend's problem right here. Because this is the y-intercept, because when t equals 0, the y value is 4,000, we can take from that that our friend's principal is 4,000. Now also, if you look here at the graph, when the year equals 10, we can go all the way up here, and we can see that it's greater than 7,000. It's almost it's about 7.25. So about 7,250 when t equals 10. So now we can answer some of these questions. So which account has a greater principal? We see that our principal was 4,500 and theirs was 4,000. So our account had the greater principal. Which has a greater balance after 10 years? We just determined that ours after 10 years was 6,700, and by looking at the graph, we saw that theirs was 7,200. So we find out that ours had a greatest principal, but our friend's has a greater balance. Now, let's try to see what the rate of change is between their account and our account. But because we started with more money, you'd think that we'd end up with a higher balance, but we didn't. So their average rate of change should be higher than ours. Let's go ahead and check it out. So if we look at our account, our value at 10 years was 67.13. If we subtract our initial value, divide that by 10, our rate of change was 221. Okay, that was our rate of change. If we look at our friend's account, we take their value at 10 years minus their initial value, then divide it by 10, their rate of change was 325. So that makes sense. They had a higher rate of change, which is why they ended up with having a higher balance, even though they had a lower principal. So you can see right here, there's a lot of different things you can do by playing around and trying to understand these problems. This is fun because you can see having a larger initial investment doesn't always mean that you're going to have the highest return on that. Things like rate of change are generally more important than how much you put into an account.